Hi everyone. So my name is Joe Su. So I'm the CTO and co-founder of Appier. So today I'm going to share about the Appier's the latest report on how we our experience applying AI to fight against app frauds. So here's today's agenda. So first I'm going to just give a brief description about what is app fraud. And then I'm going to talk about the traditional way of fight against app frauds. And then I'm going to talk about the Appier's experience applying the AI-based approach to fight against app frauds. Then I'm going to just give you the reports of what are our findings about applying our Appier's way of using AI to fight app frauds, and some cases we found through our experiment. So in the recent years, app frauds has become a major threat to the ad industry. So according to ANA, the app fraud has caused 6.5 billion loss in the whole ad industry, and also these app frauds have affecting all kinds of digital advertising. So what is app fraud? So to give a very simple definition is that app fraud refers to impressions, clicks, or installs that try to disguise as legitimate traffic. So one way to look at this app fraud is we can categorize in two ways. So one is human-based traffic, and the other one is non-human-based traffic. So for this kind of human-based, human-sourced app frauds, is all or some of the advertising traffic is generated by human. So I'm going to just pick three of them to just give into the details. So for example, this kind of location fraud is that, so say you want to target at users in Korea, and the annual give you traffic claim that they are users in Korea, but actually they are actually users from other countries, for example in China or something. That we call this as location fraud. Another means is domain spoofing. Is that so you say you are targeting at users on naver.com, and also the annual claims that they give you traffic from naver.com, but actually this traffic are from some other random websites in other countries. So another type is this kind of domain stuffing or click injection. Is that so you still get their computer program generate fake clicks that make your tracking service believe that the installs come from your app, but actually it's not. It's actually generated by the computer program, but the installs still come from a real human. So here's another type of app fraud we call is non-human based. So in this category, there's all the traffic, including the impression, click, and action. They are all coming from computer programs. So for example, this kind of one of them is the bot or bot network. This all the one or a collective of infected computers designed to generate the traffics. So a more advanced one is this kind of the ghost website. This is the kind of the websites or apps. All the traffics in those websites or apps are traffic generated by the bots. So all the advertising spending on those websites are actually contribute to those computer generated, not real human. So here we look at the characteristic of this suspicious traffic. So one of them is a low retention rate. So based on our Appier's data, we see a 2.6 times lower retention rate compared from this fraudulent suspicious traffic to the normal traffic. So another characteristic is this unusual click to install behavior. We see a very abnormally high concentration in a short period of time of click to install time from this fraudulent traffic. So app fraud affects the bottom line of ad spending. So from data, we see that the retention rate from this fraudulent traffic have 157% lower, and if we look at the return on the ad spending, it's 900% lower from this fraudulent traffic. So also we see that the app fraud is evolving constantly. So in the early days, these frauds are just some simple bots, just purely generate the volume of traffics. But in nowadays, as app frauds, people start realizing app frauds, we are building the app filters. So app frauds are getting more and more sophisticated. They are start to mimic some human behavior in order to get around this kind of app fraud filters. So that's why as the efforts getting more and more sophisticated, we see a limitation of traditional way of handling efforts. So traditional way of handling efforts is you based on some simple rules defined by humans to filter faults. For example, you can have a blacklist of IP address or device IDs that for those IP addresses that generate a large amount of installs. Or you can just have a blacklist saying that, or you can blacklist IP address from those countries you don't want. But the problem is that as a sophisticated files are it's harder for the traditional way of approach to detect. For example, there are click farms, they are hired humans specifically to generate the traffic by human. And also there are malicious apps, there are infected apps get installed on end user devices to generate fake traffic. And also there are botnets. They are the collective of infected devices to generate traffic. So for those kind of early days simple files, you can just have some simple rules. For example, the click submit or click ejection, you can just have a CTIT time, click to install time limitation to block them. Or for this kind of location spoofing, you can just blacklist by country IP address. However, for those kind of more sophisticated type of files, you cannot just have, there's no simple rules to block all of them. So we see that you cannot just simply rely on human to fight efforts. Here comes we have AI can help us to fight against efforts. So one of the advantage of AI-based approach also is that it can analyze high dimensional data. So when we are talking about fighting efforts, one dimension represents one signal, for example, click to install time, or a combination of signals, for example, the click time times the action time. So when the human-based approach, when the human doing this kind of fault analysis, that usually the human can only look at 1 to 3 dimensions at one time, whereas the AI-based model can look at maybe tens, even up to hundreds of thousands of dimensions at one time. So this enables the AI to make use of all the data to detect more sophisticated type of efforts. So another advantage offered by the AI approach is the ability to do self-learning. So all kinds of anti-fault model is that you still need to define some rules to filter out the faults. So the traditional method is rely on a human to look at the data and then define the rules. And if there are rules need to be updated, you still need a human to look at data again to update the rules. So for the AI-based approach, yes, we can have the system to do self-learning so let the AI system to look at the data by itself and update the rules by itself. So this enables the AI-based system. This enables the AI-based system to update the rules in a more rapidly to handle the new and more sophisticated type of faults. Okay, so here's one thing where you can see how the AI-based approach works. So this is one type of model in Appier we use in AI to fight against faults. We call this is a tree-based model. So for the traditional human-based ways that you define a rule. For example, you can say the CTIT time, if is the CTIT time more than 10 seconds. If yes, then I say, okay, it's a valid traffic. If no, I say it's a fraudulent. So when the AI-based approach, we can have a chain of these kind of rules. For example, we can have a rule 1 saying that is the traffic from Korea. And the rule 2 saying that is the traffic from the university. And the rule 4, I can say, is the install from at night. So each tree can look at a combination of this dimensional data. And we can have a group of trees, a forest of trees, to jointly to help us decide if a traffic is a fault or not. So here's a quick summary is that the difference between the traditional way and AI-based approach of fighting efforts. The traditional approach you have a human to analyze maybe up to 1 to 3, have rules up to 1 to 3 dimensions. Whereas your AI-based approach, you can have a system to look at a much higher dimension data to define the fraud filtering rule, and also have a system to update rules by itself. So here's one of the system we built at Appier. So we have this 3-stage system. So when we get the traffic, we have it pass through the basic filtering. We still have some simple rules, just to filter out some basic type of fraud. So we have, and after the traffic pass the basic filter, we have this AI-based model filter, to filter out more sophisticated type of fraud. So after this filter, we acquire traffic. We run a post-verification filter on those acquired traffic to revalidate if the acquired traffic is a fraud or not, and then based on results, update the model we use in the stage 2 and stage 1. Okay, so yeah, I'm going to share with you about some of the data after we deploy this AI-based approach to fight against fraud. So Appier have started building this system this year, and all the data that I'm going to share in the next few slides are based on the data we collect from the July and August this year. So this is one of the very typical fraud pattern detected by our AI. Is called click spamming. So here we see that there's a fraudulent traffic. This in the dark blue one. So the device behavior from this fraudulent traffic is that, so very abnormal is that it has a high number of clicks within 1 hour. So in this example is that we see all the devices from this traffic have an average out at 4 clicks in 1 hour. Whereas from the normal traffic, most devices only click 1 time or up to 2 times in 1 hour. So the next one is this is a more sophisticated pattern we found through the experience. We call it a chameleon. So in this kind of, from the traffic source from this particular publisher is that, so in the beginning, all the number of installs and retentions looks normal. It's not until the day 9 it starts pumping in the traffics pumping the installs that doesn't have any retention. So we guess that they do this in order to get around those kind of simple rules to filter out traffics in the beginning by to get around those kind of traffic filtering, only look at the beginning. So this is another type of more sophisticated type of fraud. We call this inventory burst. So from this, what do I see is that also in the beginning, this kind of the publisher looks all the same, very very normal. It's not until the day 9 that this particular publisher have a lot of very small websites generating traffic. And if you look at the source of each one individual website, they only generate a few installs that it's hard to distinguish if they are fraud or not. But if you look at all the traffic collectively together, you can see there's something wrong with the traffic. So once after we deploy this AI-based approach, we found that our new AI-based approach detects 2 times more suspicious installs than the traditional approach. And so if we look at the return on ad spending, our AI-based approach helped improve 4% of return on ad spending in the APEC region campaigns. And if we look specifically for Korea campaigns, it's increased by 4.3% in terms of the return on ad spending. Okay. So here's a summary. So first is FRS is hurting the whole ad industry, and also the FRS is getting more and more sophisticated. So the traditional way of handling FRS is getting harder and harder to deal with this kind of sophisticated FRS. So we see that this AI-based approach of fighting against efforts offers several advantages over the traditional way, because it can look at much more higher dimension way of data than traditional approach, and also the system is capable of improving by itself. So based on the Appier's experience of applying AI to fight against frauds, it can detect more suspicious traffic and also improve the return on ad spending. So that's all I'm going to share today. Thank you very much.